Hello, in this video we're going to get started on the elbow pinning and elbow sliding. But before we do, what I'm going to do is just come up to bookmarks and say create bookmark, and I'll just call this joints node graph just so we can get back to it at a later date easily. And just as before, I'll take over my Word document and we can have a look at the expression. So the red text is information that we're going to have to introduce to our node graph. So we'll have to define pin len, and you can see I've defined it for the upper arm. Pin len is equal to the upper arm this_shape.distance times this section here. Obviously for the lower arm it's going to be the lower arm distance. Then we come down here and we have our if statement and our actual definition of the variable pin. So if the pin len is greater than the bone length, then we're going to redefine pin to be the pin len, and then down here we're doing some linear interpolation, and we can do this quite easily with a blendTwoAttr node. So basically, if our pin P, which is on our arm control, I'll just show you that. If pin P is equal to 0, then what we're going to get is our stretching and soft decay and stuff like that. But if it's set to 1, then this first term here is going to be overwritten because it's 1 minus pin P. It's a bit of a shame that it's going over two lines, but 1 minus pin P, which means that this first term is 0, and then we just get pin P times 1, and that will obviously just return the pin P. Sorry, the pin value. And the pin value is either going to be the bone length for the respective joints, so that's either 3 or 4, or it's either going to be, if we're inside of this if statement, the pin length, which is either going to be the upper arm distance or the lower arm distance multiplied by this section here, which allows us to negate the scale. Okay, so let's get started on that. We'll start just by creating this upper arm section here. So here is our node graph here, and we're working on the lower arm, so I'm going to create my nodes up here, and I have shapes on, which means I can come down to upper arm distance, get my shape, place it over here. Now I know this node here is 1 divided by root scale x, so I can just apply that up here. So I'll just say multiply divide, distance goes into the first one, output x goes into the second one, and that's just created our pin len. We'll need our pin P, but that's fine because we have our arm control which contains that already in the graph. So now what we need to do is create a conditional node, and that's for this section. Remember, the else statement, which you'd normally think comes afterwards, is actually being defined up here. If you define it up here, it means that you don't actually need to put in an else statement. So, condition. So if the pin len, which is output of x, first term, is greater than the bone length, which for the upper arm, which is what I'm going to, or yeah, for the lower arm, which is what I'll work on, is 3. I think I pressed 3 there. 3. Then what we want to do is return as true the pin len. So we see true R, and if it's false we just want to return the bone length, so that's 3 there. So that's that set up. Now what we need to do is create a blendTwoAttr node, and this is what's going to allow us to do this linear interpolation here in the red. So again, I'll take it over here. The first term has to be our original set of terms here, and then the second term is our newly created pin information. So that means that we need to place the output into other, and I'll just say input outcolor R, one there, and again we'll blend that using our pin. Okay, so we have our pin attribute here, which is defined with the if statement we just created, and now we're blending it with our pin P, and we have our original statement there. Now we'll just do the same, but for the lower arm. Middle mouse drag the shape in here. Multiply, divide. We want the first term going to the distance of x. And now we've created our pin len, this time using the lower arm. Next we do a condition. And the condition is if the pin len is greater than the bone len. Now this time the bone len is going to be 4, greater than. And I know if it's false, I want to return the bone len. And if it's true, I just want to return the pin len. So we can place this in the first term, and the color if true. And now we need to put in our condition node. Oh, I beg your pardon, not condition node. Our blendTwoAttr node. And again, our first term into this needs to be our output 1D. Second one. And we're going to blend that using the pin parameter or pin attribute on our arm control. And we'll wire the output into our wrist translate X. Let's minimize this and see what we've got. Go to our channel box, place pin up to 1, and there you can see we have our elbow pinning. And again, you'll notice that it only takes effect when the distance between our elbow locator is less than the distance between the upper arm locator and the wrist locator, or the soft blend locator. So now that's done, what we need to do is introduce our slide in here, because that's still something that we haven't done. And again, you'll notice that we're going to eventually return slide here. So we're going to define it first of all so that we don't need to, again, this is just an expression, we're going to define it here so that we don't need to place an else statement here. But what this means is we'll just need to take in our slide P from our arm control, set up a condition node. If it's less than 0, we'll have this evaluate, else we'll have this evaluate. Okay. So let's start, I'll just lay out the graph again, and this is where things get a little messy, as you can tell. Let's just place a condition up here. Here's arm control. Here's slide. And I'll say first term less than 0, that's fine. Less than 0. And now we have to define these things here. So we need the chain len multiplied by 3 divided by 7 times slide P, and you'll notice in a previous video I labeled 2 multiply divide nodes, divide 3 by 7 and divide 4 by 7, and this is one of the reasons, just so we can use them again here. So let's just start by getting a multiply divide node. Chain len is 7, of course, and we'll get our divide 3 by 7 here, output x, input 2x. There we go. Now we need to feed this into another multiply divide. So far we've done this. We need to introduce our slide from our arm control now. And that's going to go into the color if true R, and we also need to set up a color if false as well. So again, we have a 4 divided by 7 down here, so get another multiply divide, and now we're going to do the color if false section, which is this here. So the only difference between these two is this section here. So this is going to be 7, because that's the chain length, and we can multiply that by 4 divided by 7. Then multiply that by our slide P. So that's just done this entire section here. Now we need to add it to the lower arm, and we need to subtract it from the wrist. Okay. So I'll just create a plus minus average, and I'll just move all of this out of the way. And sum is fine, and we want to sum. Let's just see where this is going first of all. First one, output into here, out color R, here, and this is going into the input 0 of the blendTwoAttr. So that's replaced that. And we can also create a plus minus average for the wrist as well. And I mentioned actually in the first video, the introductory video, that whenever you do elbow sliding, if the lower arm moves in the positive value of parent space, which stretches the upper arm, then the wrist must move in the negative parent space, which has an effect of contracting the lower arm. That's why we have one plus minus average node, which is going to be set to sum, and the other one is going to be set to subtract, just so that we actually keep the overall length of the chain. So I'll just change this to subtract. And I'll say out 1D, and now we can place this into input 0, and I'll lay out the graph again. Actually, I'll just make this condition a bit smaller. There we go. And now if we take off our pinning, there's our slide, elbow sliding. However, what you'll notice is the elbow sliding works in some cases. If we turn on our stretching and we stretch our IK, and now we try and slide our elbow, you can see now it doesn't go all the way back and it doesn't go all the way forward. If we turn off sliding and we position our arm control back to where it was originally, and now we turn on pinning, no matter what value we set the slide to, that won't have an effect on our pinning. So even if I put this to slide value of 1, which should be all the way down at the wrist, the slide is not going to, the pinning isn't going to pay any attention to that. The reason for that, why the pinning doesn't pay any attention to slide, is because the pinning is actually in a different section of this equation. Remember, we used the blendTwoAttr, which is linear interpolation. In other words, when pinning is equal to 1, it overrides this section, which includes our slide attribute here. So that's why it doesn't interact with pinning, and it doesn't interact properly with our stretching, because we're using a fixed value of our chain length. So obviously when our joint chain is equal to our chain length, then this works fine. But as soon as our the joint chain gets stretched, then having a fixed constant value for our slide doesn't work, because it's not updating with how the joint chain is actually being stretched. So in the next video what we're going to do is redefine our expression or our node graph to take into account some of those changes.